Good morning, everyone. How are you? How's everything? So, I told you about the Fourier series yesterday, and today I'm going to solve a problem for you to understand how we deal with the Fourier series when it comes to problem solving. So, imagine we have this function x of t equals 3 plus 2 cosine of 2t plus 5 sine of 3t plus 1. So we would like to find the Fourier series coefficients ak for the following signal. So how to deal with it? There you go. I wrote the question for you on a piece of paper. And here is the solution. Look, first of all, this is the x of t. x of t was 3 plus 2 cosine of 2t plus 5 sine of 3t plus 1. Using the Euler's formula, we will expand cosine of 2t and sine of 3t plus 1. Here, 2 cosine of 2t will be 2 times e to the power of j2t plus e to the power of minus j2t over 2. This element, 5 sine of 3t plus 1, again using the Euler's formula, it will be 5 times e to the power of j3t plus 1 minus e to the power of minus j3t plus 1 over 2j. These two are done both using the Euler's expansion formula. So now I would like to rewrite x of t based on these two. So first I had the 3 plus. I replaced the 2 cosine of 2t with this expression that I found. So it's going to be 2 cancels with this 2 in the denominator. So it's going to be 1, basically 1 e j to the power of 2t plus 1 e minus j2t. Plus, how do I write this one? Look here, I have e to the power of j3t plus 1. Of course, I can get rid of this 1 by writing it as e to the power of j times e to the power of j3t. The same here. So basically, I am having the coefficient looking like this. 5 over 2j, which is coming from the denominator, times e to the power of j, which is coming from this 1 in the power. So the coefficient will be 5 over 2j e to the power of j, e times e to the power of j 3t, minus the same thing here, e to the power of minus j. That this minus j will come from this 1 in the power, over 2j, which is in the denominator. 5 is from here, 2j is from here, and e to the power of minus j is from here, times e to the power of minus j3t. So now we want to find the coefficients. What is a0? a0 is the constant, so a0 will be 3. What is a1? Do we have a1? No, because we don't have any e to the power of jt, so a1 is basically 0. A minus 1 is also 0. But the first thing that we have after a0 will be a2. a2 because we have e to the power of j2t. So the coefficient of e to the power of j2t will be a2. The coefficient will be 1 because it's 1 times e to the power of j2t. The same for e to the power of minus j2t. So our a minus 2 will be 1 as well. How about a3? a3 will be the coefficient of e to the power of j3t. So this right here, 5 over 2j e to the power of j, this one is a3. And this one right there, minus 5 over 2j e to the power of minus j, will be a minus 3 because it's the coefficient of e to the power of minus j3t. I guess now you know how we deal with these kind of problems and how do we find their Fourier series coefficients. Now I want you to solve this problem yourselves. It's very similar to what I solved for you with a little bit of difference. So I want you to find the Fourier series coefficients ak for this signal y of t equals 5 plus 2 cosine of t plus 4 sine of 3t plus 5 plus 3 cosine of 4t plus 2. Probably you can guess that what is your A0, right? So solve it yourselves and get back to me by tomorrow at the class time. Take care.